Most LCDs released these days are labeled quantum, starting with the TVs that were initially released under the name QLED, Samsung's Neo QLED, and now even LG. LCDs with the name QNED are coming out one after another. Moreover, even the OLED TV that Samsung plans to produce early next year has been named QD-OLED technology. Why are they so obsessed with the name QD? Today, we will talk about it. So let's start the tech tree. First, let's look at the kind of interactions materials with light. If we look at the objects around us, the interaction with light can be classified into several categories. A material that reflects most of the light, like a mirror when it receives light. A glass-like material that transmits light without any interaction with light. A dye that absorbs some wavelengths and emits only unabsorbed light, such as paint. An opaque material that scatters light to make it impossible to see inside or the other side, and the material, what we call fluorescent material, that absorbs light and emits light with a longer wavelength than the received light. The characteristics of such a fluorescent material is that it absorbs light of a shorter wavelength and re-emits light with a longer wavelength than the absorbed light. You can adjust the emission wavelengths by changing the composition of the fluorescent material. Using these characteristics, if a fluorescent material is applied with an appropriate thickness on the blue LED chip, the color of the fluorescent material that absorbs blue from the chip and emits yellow light is mixed, so that white light is emitted from the LED to our eyes. If you increase the amount of phosphor, you get warm white color, and if you decrease the amount of phosphor, you can make a cool white. There are a lot of things around us that use these fluorescent materials, from LED lamps that replaced incandescent lamps to automobile headlights. Blue LEDs and fluorescent materials are used at the same time to produce white light source. Before using quantum dots, LCDs used the white LEDs manufactured as above as backlights. A color filter is formed using a dye-based material that absorbs selective wavelengths, and RGB subpixels has been formed by extracting red, green, blue colors from the white light. However, there are hidden problems with these systems. The first is the fact that the proportion of yellow that needs to be filtered out is the largest. In other words, the green and red to be extracted is relatively small. Therefore, the loss due to the filtering is inevitably large. The second problem is that due to the characteristics of the color filter, it does not separate each of RGB narrowly, but separated into relatively broad spectrum. This is because the color filter cannot cut unnecessary wavelength band as we want. The three primary colors of light obtained with a broad spectrum have lower color expression ability on the display panel than the combination of red, green, blue obtained with a narrow spectrum. This is because red, green, blue with a broad spectrum are not the pure primary color, but a color polluted with light of nearby wavelengths. What we are trying to solve this broad spectrum problem is to introduce quantum dot instead of inorganic phosphor. So, what is a quantum dot and how does it emit a narrow spectrum? Here is one silicon atom. Silicon is very unstable in an atomic state, so it does not exist in an atomic state under normal circumstances. Silicon used in semiconductors and solar cells is bulk material made by combining countless number of silicon with each other. Since silicon atom knows which state is more stable, the atoms gather and share electrons to form bonding. By the way, by using chemical method, silicon particles composed of relatively small number of silicon atoms can be synthesized, and the growth of particles can be stopped at the desired size by controlling the synthetic condition. It should be noted here that particles with a size of 10 nanometers or less exhibit optical properties that are significantly different from those of bulk materials. In terms of fluorescence properties, which are of interest today, nano-sized ultrafine particles emit light with a shorter wavelength than large particles, and the emission wavelengths can be freely controlled from blue to infrared by simply controlling particle size. Substances of 10 nanometers or less that strongly exhibit such a luminescent characteristics are called quantum dots. Another characteristic of quantum dots emission characteristics is that the emission spectrum itself is very narrow, as mentioned above. This characteristic is because the quantum dots composed of a relatively small number of atoms express the characteristics of the energy levels of each atom to some extent. This is because energy levels of quantum dots are well-separated energy levels rather than having agglomerated bands like bulk materials. In the beginning, it was difficult to synthesize quantum dot on a large scale, but now it is possible to mass produce it at a relatively low price due to the development of technology. And the quantum dot used by Samsung is being mass produced and supplied by Hansol Chemical. The picture you see here is what we learned in school days. This is spectrum that shows the wavelengths of light on the x-axis and the intensity of light on the y-axis. When an object is emitting red light, it is a good way to indicate which wavelength is distributed with which intensity. And it's easy to know intuitively how broad the spectrum is, but to express it numerically, you have to go through mathematical processing once again. However, display engineers use a slightly different method of representing color. It is the CIE 1931 chart. The most peculiar thing is that the color itself is expressed in XY coordinates, and depending on whether the light is located on the diagram, whether the spectrum is broad or narrow can be judged. It is also a very useful method to predict what color will be expressed when the three colors are mixed at what ratio. The XY coordination of RGB constituting the subpixel is inevitably different depending on the display type. The meaning of the triangle created by connecting the coordination of three primary colors means that all colors belong to the triangle can be implemented on the display panel. A sharp spectrum like a laser is located at the border of the diagram, and as the spectrum becomes broader, it gradually moves to the center and the triangle area decreases. The display industry is consistently looking for a way to maximize the area of a triangle, and since the quantum dot shows a very narrow RGB spectrum, introducing quantum dot is the best way for now. That's why everyone is adopting quantum dot in the display method they produce and putting it in their name. When measured mechanically, the display using QD clearly has better color gamut than the conventional broad spectrum phosphor. But how much difference it can make to our eye is another matter. That's it for today. Goodbye.